In this lesson, we're going to learn to identify substances as either elements or compounds. We're only going to focus on the pure substances side of our original flow chart, looking at elements and compounds, and then how they further break down as well to be further categorized. Let's look at elements first. These are both samples of elements because they contain only one type of atom. The one on the left is known as an atomic element because all the atoms are separate from one another. The sample on the right is a molecular element because the atoms don't exist by themselves, they exist bonded to another atom of the same element. Typically, we'll only see this with two atoms, although there are some cases where we have 4 or 8 atoms connected together and they're all of the same element. So 2 or more like atoms bonded together form a molecular element. Is F2 an atomic or molecular element? F2 is a molecular element because we have 2 atoms of the same element bonded together. The diatomic elements exist in nature as diatomic elements. That means when we have hydrogen or nitrogen or oxygen, we don't have single atoms of those elements. We always see them in pairs of atoms bonded together. Remember that di means 2, so these are diatomic, so 2 atoms, and this is how they exist in nature. Notice that there are 7 of them. We have hydrogen on the left side, and then we also see the remaining 6, which form a 7, just as a reminder to us, on the right side. And it's going to be important to remember these because when we get later on and we're looking at writing reactions, we need to remember that when we talk about nitrogen, we mean N2, not just N, because these exist in nature as molecular elements. Now we're going to look at compounds. These are still pure substances because if we're looking at a sample of a compound, all of the particles of that sample are exactly the same. And what we see in a compound is that they contain 2 or more types of atoms. Compounds can be different than molecules. Some substances exist as a compound and a molecule. Some things exist as a compound but not a molecule. And we'll learn more about that as we progress through the course. So if we look on the left, these are examples of molecular compounds, and on the right are ionic compounds. And once we learn more about the periodic table and its structure and the types of elements, we'll learn more about how we distinguish between those two. But just for now, know that they both exist. Remember, atoms are individual atoms. They exist separate from one another. Molecules have 2 or more atoms bonded together. And we're going to look at some examples for things that are molecules, that are compounds, and that are not compounds. Molecules are 2 or more atoms bonded together with a fixed composition. The atoms can be the same or different. So we've seen molecular elements like F2, 2 atoms of fluorine, but we can also have compounds that have different elements in them that are also molecules. So molecules can be either elements or compounds, depending on whether or not the 2 atoms are the same or their atoms are different. Let's look at some examples. We'll start here. In this case, we see 2 atoms that are bonded together, so we know we're dealing with a molecule, and both of those atoms are the same, therefore we're dealing with an element. When we look at the next sample, we see that we have a molecule because we have 2 or more atoms bonded together, and this is also going to be a compound because the atoms are not all the same, and that's indicated by the different colors of the atoms. Here we also have a molecule because we meet that definition, and this is going to be a compound because we have different identities of atoms within that molecule. In our last example here, we see we have a molecule and both atoms are the same. Therefore, this is an element. So this will be a molecular element. Which substance is a molecule but not a compound. Let's look at our first example. Here we have a molecule and a compound. We have two or more atoms, but they are different identities of elements, therefore it's a compound. For B, we see this as a molecule and an element because we have two atoms bonded together, but the identity of the element or the atoms is exactly the same. So this is a molecular element. C would be an atomic element and not a molecule because we only have a single atom. And D is a molecule and a compound because we have multiple atoms bonded together, but we have different types of atoms. So B is the correct answer. It is a molecule, but not a compound. Which substance is an element, but not a molecule? When we look at helium, we have a single atom. Therefore, there's no way to have two atoms bonded together. So therefore, this is an atomic element. When we look at N2, we have two atoms of the same thing, and they're bonded together. They're in one formula together, so we have a molecular element. When we have C, we have C2H6. That's going to be a compound because we have both carbon and hydrogen. And don't worry if you don't know the names of the elements yet. We'll get there, but that's a compound. And NaCl, that's also a compound. And we know that because we see Na and Cl. And even if you don't know what Na and Cl are, you know that those are different from one another. So A is the correct answer. So it's an element, but not a molecule.